Welcome to day 4. We are finally moving on to something else. We are going to practice some measurements. We're going to work on volume today. Now, number 1, it's been a confusing one, and I understand with the way that it's worded. For number 1, you just need to look at the rest of day 4, okay, and list 2 of the units that we used today. Okay, so that's going to be milliliters and then centimeter cubed. Okay, so that's going to be cm with a 3 superscript. So I know that the way that this is laid out is a little strange. So number 2, to determine the metric volume of the cube below, remember, a cube is composed of 6 equal sides. So I'm going to try to, oh yes, there we go. Try to do this. Okay, so centimeters. Okay, big numbers are the centimeters themselves. Small ticks, if you have not used a ruler in a little while, are millimeters. Okay, those are our decimal points for our centimeters. So we are 1.4 centimeters cubed. So your answer for this one, number 2, is 1.4 cm with a 3 above the m. Okay, like you're doing something squared. It's a 3, so it's a cubed. Pretty simple. Coming down here, what are the values of the graduations or the unmarked lines in each of the following graduated cylinders? So for 1 here, for A, in between each whole number, we have 1, 2, 3, 4 lines. So each whole number is made up of 5 increments, okay, 5 increments. And that means that each one of these is going to be what? 1.2, 1.4, 1.6, 1.82. So these graduations down here are going to be 0.2 ml, milliliters. Okay, you can see this ml down here in the corner. Now this one, pretty much the same thing. Hold on, I'm going to have to come back to you. Izzy is yelling for me. So where were we? Sorry. Second one, B here. Same setup, except we're going by tens this time. Now, if we still have 1, 2, 3, 4, 4 small hash marks, dashes, unmarked lines, that means we have 5 segments in between each whole 10 number here. So again, we're counting by 2s, but it's just going to be 2s here and not 0.2s like over here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So your graduations here are going to be 2 ml for milliliters. Remember, that's down here. Now, I'm leaving C to you. You can do C, okay? Just count up. Make sure it looks okay. Don't forget your unit, ml, milliliters. Okay, which of the graduated cylinders from the question would provide you with the most accurate measurement for an object that has a volume of around 2 milliliters? Okay, so for most accurate, okay, if we're looking at 2 milliliters only, this is too much, okay? This is too much. These increments are too big. We're not going to get anything accurate out of them. The one that we're going to get the most accurate reading out of for a 2 milliliter object is going to be the graduated cylinder A, okay? Because if it's 2 milliliters, okay, and we add something in, we can see the 10th place move, right? If we put that in here, it's not going to be, we're not going to see enough movement. Okay. What do you call the curved upper surface of water that commonly appears when using a graduated cylinder? So that's this thing right here. See that dark thing? That is called a meniscus. Okay. I know if you had Mr. Stansberry, you did this. Okay. I know you did. Meniscus. I'm not going to tell you what causes it because if you're on the computer, you can Google that yourself. What is the volume of liquid? When you're looking at these, you need to make sure, okay, that you're looking at the bottom of the meniscus. So the bottom of that line, not the top. Okay, you need to look at the bottom. Now, they were nice enough on these pages to make sure that A, B, and C were the same cylinders from up top. So if you remember here, each one of these unmarked lines was 0.2 milliliters. So here we have 2.2, 2.4, 2.6, 2.8 is where our meniscus is reading. So your answer down here for volume is going to be 2.8 ml. Okay, I'm leaving these to you. I'm leaving these to you. 7. What do you call the procedure that helps you determine the volume of an irregularly shaped object while using a graduated cylinder? How do you perform the procedure? What's that called? Google it. Okay, Google it. It's not that hard. You can find it, I promise. 8. So this is that practice from number 7. So if we start here, okay, we start with what, 24 approximately 24 milliliters, okay, and we put the object in. See, here's our rock. We drop that object in, okay, it displaces some of that water, and we're going from 24 milliliters to 38 milliliters. What's the difference? 38 minus 24 is going to give you 14 milliliters. Okay, 14 milliliters is how much volume your rock has. Okay. Oh, well, that's it for day 4. Make sure you're Googling those questions. Day 5 is going to be a quick one.